Hello, welcome to Calculus here at Cañada College. My name is Lapuz. In this video, we will be looking at this checkpoint 6.21 from section 6.4, where it is asking us to evaluate the integral of the cosine of the square root of x dx as an infinite series. Now, it's probably, if you tried to do this using regular integration, I don't know if any of our integration techniques would help us get the solution for this. So, one way people have dealt with this is with series, and then you can evaluate definite integrals and minimize the error, or have the error to be as small as you need it to be. So in this case, they want the error within 0.01. Okay, first we need to know the series for cosine. So cosine x, just x by itself, is going to be, this is the even function of the trig between sine and cosine. So we'll have even power functions. So that's going to be 1. It's an alternating series, if you remember. The next one is x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, etc. And if you remember the general nth term, it's going to be, again, an alternating series. And then x to the 2n, because it's only the only the even powers, and then divided by the same power as the factorial in the denominator. Okay. So our task is to evaluate this now at square root of x. So we have cosine of square root of x. So that means wherever we see an x, we will put a square root of x there. Now, putting a square root of x is equivalent to putting x to the 1/2 power. Since we're going to be combining powers, it might be useful to write it as x to the 1/2 power. So, let's see. After we do that, it would be helpful to do some simplifying. So if we're going to put x to the 1/2 power, we're going to think about multiplying the powers together. That's one of the rules that we have. And then we will get 1 minus, this is 1/2 times 2, which is just x over 2 factorial. And then this would be x squared over 4 factorial, and x to the 3rd over 4 over 6 factorial. So I think we get the general pattern here. We still have an alternating series, and this would just be x to the n over 2n factorial. Okay, so that is that. Now comes time where we integrate. So we integrate, we integrate, we integrate. And when we integrate this, we will get our value that we want, or at least for the first part, a series cosine of square root of x dx is equal to. So the antiderivative of 1 is just going to be x. The antiderivative of this is going to be x squared over 2, but we still have a 2 factorial in the denominator. And before I multiply that out, I will keep it like that just so we can see a pattern emerge, maybe. We have a positive here. This is going to be an x cubed over 3, and then we still have a 4 factorial in the denominator. And then now a negative x to the 4th over 4 times 6 factorial. And so the pattern goes, if we integrate the general nth term, this is going to be x to the n plus 1 divided by n plus 1, and then the 2n factorial and the negative 1 to the nth is constant, so that does not change. So here is our series. And if you want, since we do have the nth term over here already, we can say this is the integral, and I would go with 1 here. Should I go with 1? I think we can go with 0, because the first term is going to be x to the n plus 1. So there's a negative 1 to the n power. So the 0 term would be positive, the next term would be negative, so that looks like it holds. X to the n plus 1, so when n is equal to 0, this is x to the first power, and that's the first term, so that's great. And then the rest should follow, n plus 1, and then 2n factorial. Okay, so this is your general series for the cosine function. That's great. Now they want us to evaluate this from 0 to 1. So evaluating this from 0 to 1 would simply tell us to put 0 and 1 there. So notice that if we put 0, we're going to get 0. Well, let me write it out. X minus x squared over 2 times 2 factorial plus x to the third over 3 times 4 factorial plus x to the fourth over 4 times 6 factorial dot dot dot. If we're going to evaluate this from 0 to 1, all these terms with a 0 is going to disappear, and so we just have to put 1 in for x. So what are we going to get? We will get 1 minus 1 over 2 times 2 factorial plus 1 over 3 times 4 factorial plus 1 over 4 times 6 factorial. And then we got the pattern here, right? So it's going to be a negative 1 to the n, and then 1 over n plus 1 times 2n factorial. So this is going to be the number that we're looking for. Now they want us to estimate this with an error of 0.01. And so what might be a good idea is to try to figure out how much each of these contribute to our values. And so for that, we can use a graphing calculator or a Desmos. And so let's put Desmos aside over here. We don't need the graph of this per se, but we just want to see what looks like it's happening when we compute each of these terms. So let's start with 1 over 2 times 2 factorial, and we get 0.25. So that's not very, that's still a significant amount. Let's take a look at 1 divided by 3 times 4 factorial. That's 0.01, so that looks like it's contributing a little bit still to within that error that we want. But if we go 1 divided by 4 times 6 factorial, then we're contributing less than 0.0003 as part of what we're adding on to this. And looking at my work, it looks like I put pluses where it was supposed to be minus. So I'm going to go 0.25, 0.014, and 0.0003. So this, I saw this while I was looking at the Desmos, so let's put that. So 0.25, this is 0.014, this is 0.0003, whatever. So it looks like at this point here, we're going to get less and less contributions. Less contributions to our sum. And so I think our best approximating values would be up to here. So 1 minus 1 over 2 times 2 factorial plus 1 over 3 times 4 factorial. All right, so let's take a look at the result for that. And this is going to be, let's add them up. So we have 1 minus 1 over 2 times 2 factorial plus 1 over 3 times 4 factorial. And I get this value 0.7638. So 0.7638. Just for reference, and just because we can, let's actually integrate and get a numeric value for the integral of the cosine. So let's see. Let's integrate from 0 to 1 of cosine of the square root of x dx. And I think maybe I'll put this in parentheses and then get our value. So if we look at this value here, we'll see that it is very close to our estimated value of what we're seeing. And if we look at that, we could see that it's good for 763, and then it's good up to here, and that's an error that's within 0.01. All right, I hope that helps. Good luck.